I am the virtual teacher at Egnatia Career College. Today we'll teach branch circuits for bathrooms, lighting branch circuit and small appliance circuits for the kitchen, special purpose outlets for ranges, counter-mounted cooking units, wall-mounted ovens, food waste disposals and dishwashers. This is video number 11. Branch circuits for bathrooms. After studying this unit, you should be able to list bonding requirements for bathroom installations, discuss fundamentals of proper lighting for bathrooms, explain the operation and switching sequence of the heat/vent/light/night light, describe the operation of a humidistat, install attic exhaust fans with humidistats, both with and without a relay. List the various methods of controlling exhaust fans. Understand advantages of installing exhaust fans in residences. Understand the electrical circuit and Canadian Electrical Code (CEC). Requirements for hydromassage bathtubs. Electrical equipment in bathrooms and washrooms requires special installation considerations. For example, in the residence used as an example in this textbook, the hydromassage bathtub in the inside bathroom requires ground fault circuit protection, Rule 68-302. Switches must be properly located. There must be enough circuits to operate all of the equipment without the possibility of overloading circuits. It is also important to correctly locate luminaires to achieve proper lighting. The vanity lighting for the two bathrooms is provided from the circuit that supplies the ground fault circuit interrupter, GFCI, protected receptacle in each bathroom, A20 and A22. Because the receptacles in the main bathroom and in soot bath are likely to be used in the morning at the same time by people using hair dryers that draw as much as a toaster or kettle, 1200W. We have put the receptacles on their own circuit with the vanity lights. This is not a CEC requirement. Each bathroom has a combination ceiling heat, vent, and light. Nightlight ceiling fixtures unit that is connected to separate circuits shown as J and K. A hydromassage tub, located in the bathroom serving the master bedroom, is connected to a separate circuit A. This figure and the electrical plans for this area of the home show that each bathroom has a fixture above the vanity mirror. Some typical fixtures are shown here. The homeowner might decide to purchase a medicine cabinet complete with a self-contained lighting fixture. This figure illustrates how to roughen the wiring for medicine cabinets with or without such a lighting fixture. These fixtures are controlled by single-pole switches at the doors. A bathroom or powder room should have proper lighting for shaving, combing hair, putting on makeup, and so on. If the face is poorly lit and in shadow, that is what will be reflected in the mirror. A lighting fixture directly overhead will light the top of one's head, but will cause shadows on the face. Mirror lighting and/or adequate lighting above and forward of the standing position at the vanity can provide excellent lighting in the bathroom. These figures show pictorial and section views of typical soffit lighting above a bathroom vanity. The receptacles in each bathroom are located adjacent to the vanity and within 1 meter of the wash basin, Rule 26-720F. Bathroom receptacles must be at least 1 meter from the bathtub or shower when practicable, Rule 26-720G. As required by Rule 26-704 and as discussed in Unit 9, these must be GFCI receptacles. Section 0 defines a bathroom as a room containing a wash basin together with bathing or showering facilities. Switches controlling lights must not be within 1 meter of the shower or bathtub, Rule 30-323. General comments on lamps and color. Incandescent lamps, light bulbs, provide pleasant color tones, bringing out warm flesh tones similar to the way that natural light does. With fluorescent lighting, you should use fluorescent lamps that bring out the warm flesh tones, such as Warm White, WW, and Warm White Deluxe, WWX, which simulate incandescent lamps. Or Cool White Deluxe, CWX, which simulate outdoor daylight on a cloudy day. White W, or Cool White, CW, fluorescents downplay flesh tones and give the skin a pale appearance. Compact fluorescent lamps provide excellent color rendition. With respect to color, LED lights refer to the degrees Kelvin equivalent of a black body radiating at some temperature. Thus, an incandescent light that is yellow in appearance would radiate light at 2700 to 3000 degrees Kelvin. The fluorescent light found in an office would be 4000 to 5000 degrees Kelvin. Different combinations of colors enhance the ability of the human eye to see different features. Lighting fixtures in bathrooms. Rule 30-321 requires any light fixture, luminaire, or lamp holder that is located within 2.5 meter vertically or 1.5 meter horizontally of bathtubs, laundry tubs, or other grounded surfaces to be controlled by a wall switch. The switch must be located at least 1 m from a tub or shower so that a person standing in the tub or shower will not be able to reach the switch. In installations where this distance is impracticable, the CEC does allow US to reduce this distance to 500 mm. However, the circuit must be ground fault protected. Hallway lighting. The hallway lighting is provided by one ceiling fixture controlled with two three-way switches located at either end of the hall and supplied from circuit A16. Receptacle outlets in hallways. One receptacle outlet has been provided in the hallway, supplied from circuit A14. Rule 26-724F requires that in a dwelling unit, no point in a hallway shall be more than 4.5 meter from a duplex receptacle. Bonding requirements for a bathroom circuit. All exposed metal equipment, including fixtures, electric heaters, faceplates, and similar items, must be bonded. The bonding requirements for bathroom circuits and any other equipment in a residential building are contained in Section 10. The 2018 Code revised Section 10 to simplify bonding by characterizing it as adding a conductor that acts as a low-impedance path to ground for unwanted or dangerous electrical currents. In general, all exposed non-current carrying metal parts of electrical equipment must be bonded together and connected to ground in order to establish equipotentiality, that is, to ensure that all equipment is at the same electrical potential. If the voltage is the same at all points, then no current can flow. If wiring supplying the equipment contains a bonding conductor. If the ground or a grounded surface and the electrical equipment can be touched at the same time. If they are located in wet or damp locations, such as bathrooms, showers, and outdoors. If they are in electrical contact with metal, including metal lath and aluminum foil insulation. Equipment is considered bonded to ground when it is properly and permanently connected to a metal raceway, a separate bonding conductor, or the bonding conductor in non-metallic sheathed cable or armored cable. The bonding conductor must itself be properly grounded. In general, residential cord-connected electrical appliances must be grounded. Many appliances, tools, and devices require no ground pin because they are double insulated or constructed from non-conductive materials that prevent the case or frame of the device from becoming hazardous in the event of an internal fault. Occasionally, reliable grounding cannot be obtained and equipment must then be supplied from a double-insulated portable Class A GFCI. Double-insulated appliances must clearly be marked, or with the words double insulated, and do not require a separate bonding conductor. These appliances are furnished with a 2-wire cord that is designed for a polarized receptacle. The short blade must be connected to the hot conductor and the long blade to the neutral or identified conductor. Residential electrical appliances that must be grounded, unless double insulated, are facial saunas, freezers and refrigerators, clothes washers and dryers, dishwashers, aquarium equipment, handheld motor-operated tools, air conditioners, electric motor-operated hedge trimmers, lawn mowers, and snow blowers, sump pumps, Bathroom ceiling heat, vent, light circuits. In the ceilings of both bathrooms is a combination heat, vent, light, nightlight, similar to the one shown in this figure. The symbols K and J represent the outlets for these units. The bathroom ventilation units are heat/vent/light/nightlight combination units. Each unit consists of a 1500 watt heater, separate heater and ventilation motors rated at 0.9 ampere each. A 7 watt night light, and either a 100 watt incandescent or 13 watt LED light bulb. The unit is IC rated for installation in ceilings insulated to R40 and has a sound rating of 3.5 sones. The unit is not designed for mounting over a tub or shower stall. The unit has been tested and certified by CSA standard C22.2 for electric air heaters. According to the manufacturer's specifications and installation instructions, the minimum circuit requirements for the unit are 120 volts, 18.6 amperes, 60 Hz. The actual full load current based on a 1500 watt heater, two 0.9 FLA motors, a 60 watt main light, and a 7 watt night light would be 14.9 amperes. It must be wired on a separate 20 ampere circuit. Install number 12 AWG copper NMD 90 cable from the panel to a 2-gang switch box, and from the switch box to the bathroom heat, light ventilation combination unit shown in this figure. The switches must be located so they cannot be reached from the tub or shower. A single gang box is used for the vanity light. Operation of the heat, vent, light. The heat, vent, light is controlled by 4 switches. 1. One switch for the heater. 2. One switch for the light. 3. One switch for the exhaust fan. 4. One switch for the night light. When the heater switch is turned on, the heater blower motor starts and the heating element begins to give off heat. The heat activates a bimetallic coil attached to a damper section in the housing of the unit. The heat-sensitive coil expands until the damper closes the discharge opening of the exhaust fan. Air is taken in through the outer grill of the unit. The air is blown downward over the heating element. The blower wheel circulates the heated air back into the room. When the heater is turned off and the exhaust fan switch is on, only the exhaust fan is on. The air is pulled into the unit and is exhausted to the outside of the house by the blower wheel. Bonding the combination heater. To bond the unit, connect the bare bonding conductor of the non-metallic sheathed cable, NMSC, to the bonding terminal or lug on the unit. When connecting exhaust ducting to the unit, it is critical to vent the unit to the outdoors. If a unit is vented to the attic, the moisture in the warm exhaust air will condense in the attic during the winter, which can cause a buildup of ice on the inside of the roof, resulting in significant damage to the structure of the building during freeze-melt cycles. It also reduces the effectiveness of the ceiling insulation. Hydromassage bathtub circuit. The ensuite bathroom is equipped with a hydromassage bathtub, sometimes referred to as a whirlpool bath. Pools, tubs, and spas are covered by CEC Section 68. Rule 68-050 defines a hydromassage bathtub as a permanently installed bathtub having an integral or remote water pump or air blower and having a fill and drain water system. Electrical connections. The hydromassage tub is fed with circuit A9, a separate 15 ampere, 120 volt circuit using number 14 AWG NMD90. This picture shows typical wiring diagram of a hydromassage tub showing the motor, power panel, and electrical supply leads, lighting branch circuit and small appliance circuits for the kitchen. After studying this unit, you should be able to explain the Canadian Electrical Code (CEC) requirements for small appliance circuits in kitchens. Understand the CEC requirements for receptacles that serve countertops. Discuss split circuit receptacles. Discuss multi-wire circuits. Discuss exhaust fan noise ratings. Discuss typical kitchen, dining area, and under-cabinet lighting. Lighting circuit B7. Circuit B7 supplies the lighting in the kitchen and service entrance as well as the outside light between the sliding doors in the kitchen and living room. There are 7 outlets on circuit B7. Kitchen lighting, outlet count and estimated load, circuit B7 are described in this table. Kitchen lighting. The general lighting for the kitchen is provided by 2 track lights controlled by 3-way switches located next to the doorway leading to the living room and at the rear entrance. All fixtures must be Canadian Standards Association (CSA) approved. An adjustable swag fixture is mounted on a track to provide lighting above the breakfast nook table. This fixture is controlled by 3-way switches, one located adjacent to the sliding door, the other at the doorway leading to the living room. Many fixtures of this type are provided with a dimmer switch to permit selection of the lighting level. Figures show other types of ceiling-mounted lighting fixtures used in kitchens, dining areas, and dining rooms. One goal of good lighting is to reduce shadows in work areas, which is particularly important in the kitchen. The 2 ceiling fixtures, the fixture above the sink and the fixture in the range hood, will provide excellent lighting in the work area of the kitchen. Track lighting in the dining nook offers good lighting for that area. Low-profile light-emitting diode, LED, pot lights are another popular lighting source in homes. Most are dimmable and can commonly be found in the more desirable 2700 to 3000 Kelvin colors that match incandescent lights in spectra. Under-cabinet lighting. In homes with little natural light, the architect might specify strip LED or fluorescent fixtures under the kitchen cabinets. Several methods may be used to install under-cabinet lighting fixtures. They can be fastened to the wall just under the upper cabinets, Part A in Figure 14-3. Installed in a recess that is part of the upper cabinets so that the lights are hidden from view. Part B in Figure 14-3. Or fastened under and to the front of the upper cabinets. Part C in Figure 14-3. All 3 require close coordination with the cabinet installer to be sure that the wiring is brought out of the wall at the proper location to connect to the under-cabinet fixtures. The installation of extra low-voltage cabinet lighting systems is covered by Rule 30-1208. Lamp type. Good color rendition in a kitchen area is achieved with incandescent lamps or fluorescent fixtures with compact lamps or standard warm white deluxe, WWX. Warm white, WW. Cool white deluxe, CXW. Or Ultralume TM 3000 lamps. Fluorescent lamps use up to 80% less energy than incandescent ones and last 10 to 20 times longer, saving on the cost of replacement. Fluorescent lighting also produces less heat, thus saving on air conditioning. For example, 2 F40 34-watt fluorescent lamps, 78 watts including ballast, provide about the same illumination as 560-watt incandescent lamps, 300 watts. When used 5 hours a day at 8 cents per kilowatt hour, a luminaire with 2 fluorescent lamps will save $32.41 annually. Still, even more saving can be achieved through the use of LED systems, which offer even greater efficiency and longevity. Range hood exhaust fan and light outlet. The exhaust fan outlet is connected to panel circuit A23 at 15 amperes, 120 volts. The exhaust fan has 2 lamps at 9 watts, 18 watts altogether, and a motor at 120 volts, 1.33 amperes, for a total wattage of 178 watts. Fans can be installed in a kitchen either to exhaust the air to the outside of the building via ducts or vents, or to recirculate the air through various types of filters, example charcoal or foam. Both types of fans can be used in a residence. The ductless hood fan does not exhaust air to the outside and does not remove humidity from the air. This figure shows a typical range hood exhaust fan. Homes heated electrically with resistance-type baseboard units usually have excess humidity. These heating units neither add nor remove moisture from the air. The proper use of weather stripping, storm doors, storm windows, and a vapor barrier of polyethylene plastic film tends to retain humidity. Vapor barriers are installed to keep moisture out of the insulation. This protection normally is installed on the warm side of ceilings, walls, and floors. Under concrete slabs poured directly on the ground, and as a ground cover in crawl spaces. Insulation must be kept dry to maintain its effectiveness. For example, a 1% increase of moisture in insulating material can reduce its efficiency by 5%. Humidity control using a humidistat connected to an exhaust fan is covered in Unit 16. Building inspectors require the vapor barrier to be intact around all outlet boxes on the outside walls of the house. It is the electrician's responsibility to maintain the integrity of the vapor barrier, Rule 12-3000 in Appendix B. An exhaust fan simultaneously removes odors and moisture from the air and exhausts heated air. The electrician, builder, and/or architect may make suggestions to guide the owner in making the choice of type of fan to install. For the residents in the blueprints that accompany this book, a separate wall switch is not required because the fan speed switch, light, and light switch are integral parts of the fan. Fan noise. The fan motor and the air movement through an exhaust fan generate noise. The unit used to define fan noise is the SON, rhymes with tone, a subjective unit equal to the loudness of a 1000 Hz tone at 40 decibels as perceived by a person with normal hearing. 1 SON is about the noise level of an average refrigerator. The lower the SON rating, the quieter the fan. All manufacturers of exhaust fans provide this information in their descriptive literature. Clock outlets. A deep sectional box is recommended because a recessed clock outlet takes up considerable room in the box. Some decorative clocks have the entire motor recessed so that only the hands and numbers are exposed on the surface of the soffit or wall. Some of these clocks require special outlet boxes, usually furnished with the clock. Other clocks require a standard 4-inch square outlet box. Accurate measurements must be taken to center the clock between the ceiling and the bottom edge of the soffit. If the clock is available when the electrician is roughing in the wiring, its dimensions can be checked to help in locating the outlet. If an electrical clock outlet has not been provided, battery-operated clocks are available. Small appliance and branch circuits for convenience. Receptacles in kitchen. This figure shows single and duplex receptacles. The CEC requirements for small appliance circuits and the spacing of receptacles in the kitchens of dwellings are covered in Rules 26-720 and 26-724. This was discussed in detail in Unit 4. Highlights are: a microwave in its own enclosure gets its own circuit, and so does a refrigerator. These small appliance circuits shall be assigned a maximum load of 12 amperes each when calculating branch circuit connectors. Receptacles may not be either directly behind or in front of the sink. The clock outlet may be connected to the refrigerator circuit only when this outlet is to supply a recessed clock receptacle intended for use with an electric clock, Rule 26-652. In the residence in the blueprints, the clock outlet is connected to the lighting circuit. Countertop receptacles must be supplied by at least two 15-ampere, 3-wire branch circuits. As an alternative, 5-20 receptacles may be used in accordance with Rule 26-724D. There must be a receptacle within 900 mm of any point along the wall behind all counters except those less than 300 mm long. Microwave enclosures must be supplied with a receptacle on a separate circuit, Rule 26-652. If no cupboard or enclosure is provided, the microwave would be powered by one of the countertop split or T-slot receptacles. All outdoor receptacles within 2.5 meters of the finished grade must be on a separate GFCI protected circuit, Rule 26-654E. Counter receptacles may be 15-ampere 3-conductor split circuit or 20-ampere T-slot receptacles. Counter receptacles prevent circuit overloading when small appliances such as kettles and toasters are plugged in at the same time, Rule 26-724D. In the kitchen, split-circuit receptacles and 20-ampere T-slot receptacles prevent circuit overloading from the heavy concentration and use of electrical appliances. For example, one type of cord-connected microwave oven is rated 1,440 watts at 120 volts. The current required by this appliance alone is I equal to W divided by E. 1,440 divided by 120 equal 12 amperes. A maximum of 2 counter receptacles are permitted on one circuit. This provides the best availability of electrical power for the variety of appliances that will be used in the heavily concentrated work areas in the kitchen. This figure shows the circuiting for the special purpose outlets and counter receptacles in the kitchen. A receptacle outlet installed below the sink for easy plug-in connection of a food waste disposal is not included in the CEC requirements for split circuits, and is not required to be GFCI protected or tamper resistant, CC 26-704 and 26-706, 2. Split-circuit receptacles and multi-wire circuits. Split-wired receptacles may be installed where a heavy concentration of plug-in load is anticipated, in which case each half of the duplex receptacle is connected to a separate circuit. An example of a 2-pole 15-ampere breaker that feeds a 3-wire branch circuits for use with kitchen split receptacles is found in this figure. Split or 20-ampere T-slot receptacles are mandatory along the countertop in the kitchen, Rule 26-724. These must be arranged so that no more than 2 receptacles are on a circuit. Any receptacle within 1.5 m of the sink must be a GFCI receptacle or GFCI protected. When a multi-wire branch circuit is used to supply fixed lighting loads and non-split duplex receptacles, the continuity of the identified neutral conductor must be independent of the device connections. Instead of making connections of the neutral at the terminals of the receptacle, the neutral is tailed in the junction box and the tail is brought out to the receptacle. Rule 14-010b requires all of the ungrounded conductors of multi-wire branch circuit except for those supplying light fixtures or non-split receptacles, which are connected to the neutral and one ungrounded conductor, to be disconnected simultaneously. Therefore, when the breaker in a panel supplying a receptacle is turned off, current cannot be flowing in the neutral conductor. Still, Rule 4-0221d requires that any identified conductor can be disconnected without disconnecting any other identified conductor. The hazards of open neutrals are covered in Unit 19. When multi-wire branch circuits supply more than one receptacle on the same yoke, a means must be provided to simultaneously disconnect all of the hot conductors at the panel board where the branch circuit originates. This figure shows that although 240 volts are present on the wiring device, only 120 volts are connected to each receptacle on the wiring device. The simultaneous disconnect rule applies to any receptacles, lamp holders, or switches mounted on one yoke, Rule 14-010b. In the case of 3-conductor split duplex receptacles installed in kitchens connected to multi-wire branch circuits, the 2-pole breaker in the panel will disconnect all ungrounded conductors of the circuit simultaneously. The local inspection authority may permit you to make connections of the neutral at the terminals of the receptacle when looping between the counter receptacles in the kitchen. General bonding considerations. The specifications for the residents and the blueprints provided with this book require that all outlet boxes, switch boxes, and fixtures be bonded to ground. In other words, the entire wiring installation must be a grounded system. Rules 10-600 through 10-614 outline what types of equipment are required to be bonded together and to ground. Every electrical component located within reach of a grounded surface must be bonded. Post lights, weatherproof receptacles, basement wiring, boxes and fixtures within reach of sinks, ranges, and range hood fans must all be bonded. Hot water heating, hot air heating, and steam heating registers are all grounded surfaces. This means that any electrical equipment, boxes, or fixtures within reach of these surfaces must be bonded. Bonding is accomplished through the proper use of non-metallic sheathed cable, armored cable, and metal conduit. When using non-metallic sheathed cable, NMSC, do not confuse the bare bonding conductor with the grounded circuit conductor. The grounding or bonding conductor is used to ground equipment, whereas the white grounded conductor is one of the branch circuit conductors. They may not be connected together except at the main service entrance equipment, where this is achieved through the bonding screw or jumper. Special purpose outlets for ranges. Counter-mounted cooking units. Wall-mounted ovens. Food waste disposals and dishwashers. After studying this unit, you should be able to interpret electrical plans to determine special installation requirements for freestanding ranges, counter-mounted cooking units, wall-mounted ovens, food waste disposals, and dishwashers. Compute demand factors for ranges, counter-mounted cooking units, and wall-mounted ovens. Select proper conductor sizes for wiring installations based on the ratings of appliances. Ground all appliances properly regardless of the wiring method used. Understand how infinite heat temperature controls operate. Supply counter-mounted cooking units and wall-mounted ovens by connecting them to one feeder using the tap rule. Understand how to install a feeder to a junction box and divide the feeder to individual circuits to supply the appliances. Install circuits for dishwashers and food waste disposals. The residence used as an example in this textbook has one built-in oven and one built-in cooktop. Checking Table A1, Schedule of Special Purpose Outlets. In Appendix A at the back of the book, we find that the built-in wall-mounted oven is supplied by circuit B6/B8, and the built-in cooktop is supplied by circuit B2/B4. Running separate circuits to individual appliances is probably the most common method used to connect appliances. However, according to Rule 26-746, 3, 2 or more separate built-in cooking units shall be counted as one appliance. A single circuit is run from the main panel to a junction box located close to both the oven and the cooktop. From this junction box, taps of smaller conductors are made to feed each appliance. These taps should be less than 7.5 meter long. Which method to use is governed by local rules and consideration of the cost of installation, time and material. This is how to use a single circuit for a separate cooktop and oven, and for a freestanding range. Counter-mounted cooking unit circuit. Counter-mounted cooking units are available in many styles. Units may have 2, 3, or 4 surface heating elements. The surface heating elements of some cooking units are completely covered by a sheet of high-temperature ceramic. These units have the same controls as standard units and are wired according to the General Canadian Electrical Code (CEC) guidelines for cooking units. When the elements of these ceramic-covered units are turned on, the ceramic above each element changes color slightly. Most of these cooking units have a faint design in the ceramic to locate the heating elements. The ceramic is rugged, attractive, and easy to clean. In the residence and the plans, a separate circuit is provided for a standard, exposed element, counter-mounted cooking unit. This unit is rated at 7,450 watts and 120/240 volts. The ampere rating is 31.04 amperes. Rule 8-300 discusses how to calculate the demand on the conductors feeding the counter-mounted cooking unit. Installing the cooking unit. CC Table 2 and Rule 14-104-2 shows that number 8 AWG and MD90 may be used as the circuit conductors for the 31.04 ampere cooking unit installation. These circuit conductors are connected to circuit B2/B4, a 2-pole, 40 ampere circuit in panel B. The electrician must obtain the roughing and dimensions for the counter-mounted cooking unit so that the cable can be brought to the proper location at the proper height. In this way, the cable is hidden from view. To simplify both servicing and installation, a plug and receptacle combination may be used in the supply line. Most cooktop manufacturers provide a junction box on their units. The electrician can terminate the circuit conductors of the appliance in this box and make the proper connections to the residence wiring, or the manufacturer may connect a short length of flexible conduit to the appliance. This conduit contains the conductors to which the electrician will connect the supply conductors in a junction box furnished by either the electrician or the manufacturer. In the residence in the blueprints, the cooktop range is installed in the island. See the plans for details. The feed will be a 3-conductor non-metallic sheathed cable with 3 number 8 AWG copper conductors, plus an equipment bonding conductor. The cable emerges from the top side of panel B, through the ceiling joists in the recreation room, then upward into the base of the island cabinet. Because the recreation room has a drywall ceiling, the cable is run to a point just below the intended location of the kitchen island, leaving ample cable length hanging in the basement. Before the gypsum board in the basement is installed, the cable must be run up into the kitchen. Later, when the kitchen cabinets and the island are installed and other finishing touches are being done in the kitchen, the built-in appliances are set into place. Following this, the electrician completes the final hookup of the built-in appliances. The plans show that a receptacle outlet is to be installed on the side of the island containing the cooktop. This outlet is supplied by circuit B15, see figure 1410 in Unit 14. Temperature effects on conductors. Before beginning the installation, always check the appliance instructions provided by the manufacturer. The supply conductors may require an insulation rated for temperatures higher than the standard rating of 60 degrees Celsius. If such information is not provided, it is safe to assume that the conductors used may have insulation rated for 60 degrees Celsius. Table 19 gives the conductor insulation temperature limitations and the accepted applications for conductors. In addition, it is important to remember that the conductors are hooked up to lugs or breakers that have a temperature rating of their own, and this imposes a limitation on the conductors. If a 90-degree C-rated conductor is hooked up to a 75-degree C-rated breaker, the conductor may not carry more current than is indicated by the 75 degrees Celsius column of CEC Table 2, Rule 4006, 1. All circuit breakers are marked with a maximum temperature of either 60 degrees Celsius or 75 degrees Celsius. General wiring methods. You may use any of the standard wiring methods to connect counter-mounted cooking units and wall-mounted ovens. Freestanding ranges and clothes dryers must be connected using receptacles and cord-connected plugs, according to Rule 26-744. Otherwise, armored or non-metallic sheathed cable (NMSC) may be used. Verify any local restrictions on the use of the wiring methods listed before proceeding. Bonding requirements. CEC Section 10 requires electric ranges, oven cooktop units, and electric clothes dryers to be bonded to ground, with a separate bonding conductor sized according to Table 16. Surface heating elements for cooking units. The heating elements used in surface-type cooking units are manufactured in several steps. First, spiral wound nichrome resistance wire is impacted in magnesium oxide, a white, chalk-like powder. The wire is then encased in a nickel-steel alloy sheath, flattened under very high pressure, and formed into coils. Thus, efficient heat transfer takes place between the elements and the utensils. Cooktops with a smooth ceramic surface offer the user ease in cleaning and a neater, more modern appearance. The electric heating elements are in direct contact with the underside of the ceramic top. These figures illustrate typical electric range surface units. Temperature control. Infinite position temperature controls. Modern electric ranges are equipped with infinite position temperature knobs, controls, or programmable touch screens. Older style heat controls connect the heating elements of a surface unit to 120 volts or 240 volts in series or in parallel to attain a certain number of specific heat levels. Some control knobs on ranges have a rotating cam that provides an infinite number of heat positions. The contacts open and close as a result of a heater bimetal device that is an integral part of the rotary control. When the control is turned on, a separate set of pilot light contacts closes and remains closed, while the contacts for the heating element open and close to attain and maintain the desired temperature of the surface heating unit. Inside these infinite position temperature controls, contacts open and close repetitively. The temperature of the surface heating element is regulated by the ratio of the time the contacts are in the closed position versus the open position. This is termed input percentage. The contacts in a temperature control of this type have an expected life of over 250,000 automatic cycles. The knob rotation expected life exceeds 30,000 operations. Heat generation by surface heating elements. The surface heating elements generate a large amount of radiant heat. For example, a 1000 watt heating unit generates about 415 BTU of heat per hour. A British thermal unit, BTU, is the amount of heat required to raise the temperature of 1 pound, 0.45 kilograms, of water by 1 degree Fahrenheit 0.556 degrees Celsius. Wall-mounted oven circuit. A separate circuit is provided for the wall-mounted oven. The circuit is connected to circuit B6/B8, a 2-pole, 40 ampere circuit in panel B and wired using a #8/3 AWG-NMD90 cable. As you see the calculations here, the current is 27.5 amperes. Self-cleaning oven. Self-cleaning ovens are popular appliances because they automatically remove cooking spills from the inside of the oven. Lined with high-temperature material, a self-cleaning oven can be set for a cleaning temperature that is much higher than baking and broiling temperatures. When the self-clean control is turned on, oven temperatures will approximate 427 degrees Celsius. At this temperature, all residue in the oven, such as grease and drippings, is burned until it is fine ash that can be removed easily. During the self-clean cycle, for safety reasons, a special latching mechanism makes it impossible to open the oven door until a predetermined safe temperature is reached. Self-cleaning ovens do not require special wiring and are electrically connected in the same manner as standard electric ovens. Operation of the oven. The oven heating elements are similar to the surface elements. The oven elements are mounted in removable frames. A thermostat controls their temperature. Any oven temperature can be obtained by setting the thermostat knob to the proper point on the dial. The thermostat controls both the baking element and the broiling element. These elements can be used together to preheat the oven. A combination clock and timer is used on most ovens. The timer can be preset so that the oven turns on automatically at a preset time, heats for a preset duration, and then turns off. Ovens are insulated with fiberglass or polyurethane foam insulation placed within the oven walls to prevent excessive heat leakage. This figure shows a typical wiring diagram for a standard oven unit. Microwave oven. The electrician's primary concern is how to calculate the microwave oven load and how to install the circuit for microwave appliances to conform to Rule 26-720H. The same rules apply for both electrical and electronic microwave cooking appliances. Branch circuit requirements for ranges, ovens, and countertop cooking units. The requirements for branch circuits supplying ranges, ovens, and countertop cooking units are covered in Rules 8 to 326 to 740 through 26 to 750. Some key requirements are: branch circuit conductors for electric ranges, countertop cooking units, and built-in ovens are based on the demand factors of Rule 8 to 300. When sizing the conductors for a range, the demand is considered to be 8 kilowatts if the range is 12 kilowatts or less. If the range has a rating of more than 12 kilowatts, the demand is considered to be 8 kilowatts 140% of the amount by which the range exceeds 12 kilowatts, Rule 8 to 300. Two or more separate built-in units may be considered as a single range, Rule 8 to 300. When a single branch circuit is used to supply separate built-in units, tapped conductors to an individual unit must have an ampacity equal to the rating of the unit they supply, Rule 26 to 742. The demand factors of Rule 8 to 300 may not be applied to cord-connected appliances such as hot plates and rangettes. When a gas range is installed, a receptacle will be required in the wall behind the range. The receptacle should be mounted as close to the centerline of the range as possible and not more than 130 mm above the finished floor, Rule 26 to 724. Freestanding range. The demand calculations for a single freestanding range are simple. Here it is one example. You can pause the video and look at the calculations. The disconnecting means for a freestanding range having a demand of 50 amperes or less shall be a cord and plug. For electric ranges, these cords and plugs are rated at 50 amperes and must have an attachment plug of Canadian Standards Association (CSA) configuration 14-50R. This figure shows the correct wiring to the terminals on the receptacle. The receptacle for this plug must be flush mounted, when practical, Rule 26 744 9, and be installed according to Rule 26 744 6. Center of the receptacle not more than 130 mm above the finished floor, AFF. As near as possible to the center line of the space the range will occupy, with the U-ground oriented to either side. Branch circuits supplying separate built-in cooking units. The branch circuit that supplies a separate countertop cooking unit and a built-in oven may be treated the same as a circuit for a single range. Remember to consult your local inspection authority before you initiate construction. The demand on the conductors is considered to be 8 kW for ranges up to 12 kW and 8 kW plus 40% of the amount by which the cooking units exceed 12 kW when the combined load of the units exceed 12 kW. This figure shows a countertop cooking unit and a built-in oven connected to a single branch circuit. The calculation of the demand load is 14,050 watt. The demand on the conductors will be considered to be calculated as 36.8 amperes. Built-in oven will be 27.5 amperes. The tap conductors should not be longer than necessary. If you are in doubt about the length of these conductors, consult with your electrical inspector. Otherwise, consider 7.5 meter to be the limit. At one time, a separate fuse or breaker was required to provide overcurrent protection for a countertop cooking unit and built-in oven. This requirement has been deleted from the CEC. Food waste disposal. The food waste disposal outlet is represented on the plans by the symbol H. The food waste disposal is rated at 7.2 amperes. This appliance is connected to circuit B19, a separate 15 ampere, 120 volt branch circuit in panel B and number 14 NMD90 conductors are used to supply the unit. The conductors terminate in a junction box provided on the disposal. Overcurrent protection. The food waste disposal is a motor-operated appliance. Food waste disposals normally are driven by a 1/4 or 1/3 HP, split-phase, 120 volt motor. Therefore, running overcurrent protection must be provided. Most food waste disposal manufacturers install a built-in thermal protector to meet CEC requirements. Either a manual reset or an automatic reset thermal protector may be used. Disconnecting means. All electrical appliances must be provided with some means of disconnecting them, Rule 14.010. The disconnecting means may be a separate on-off switch. This picture shows typical cord connection for a food waste disposal, Rule 26 744 8. Some local codes may require that food waste disposals, dishwashers, and trash compactors be cord connected to make it easier to disconnect the unit, replace it, service it, and reduce noise and vibration. The appliance shall be intended or identified for flexible cord connection. This figure shows wiring for a food waste disposal with an integral on-off switch, turning the food waste disposal on and off. Separate on-off switch. When a separate on-off switch is used, a simple circuit arrangement can be made by running a 2-wire supply cable to a switch box located next to the sink at a convenient location above the countertop. Not only is this convenient, but it positions the switch out of the reach of children. A second cable is run from the switch box to the junction box of the food waste disposal. A single pole switch in the switch box provides the on-off control of the disposal. In the kitchen of this residence, the food waste disposal is controlled by a single pole switch located to the left of the kitchen sink, above the countertop. Another possibility, but not as convenient, is to install the switch for the disposal inside the cabinet space directly under the sink near the food waste disposal. Integral on-off switch. A food waste disposal may be equipped with an integral pre-wired control switch. This integral control starts and stops the disposal when the user twists the drain cover into place. An extra on-off switch is not required. To connect the disposal, the electrician runs the supply conductors directly to the junction box on the disposal and makes the proper connections. Disposal with flow switch and cold water line. Some manufacturers of food waste disposals recommend that a flow switch be installed in the cold water line under the sink. This switch is connected in series with the disposal motor. The flow switch prevents the disposal from operating until a predetermined quantity of water is flowing through it. The cold water helps prevent clogged drains by solidifying any grease in the disposal. Thus, the addition of a flow switch means that the disposal cannot be operated without water. This figure shows one method of installing a food waste disposal with a flow switch in the cold water line. Bonding requirements. Rule 10-600 states that all exposed, non-current carrying parts are to be bonded to ground. The presence of any of the conditions outlined in Rules 10-600 through 10-614 requires that all electrical appliances in the dwelling be grounded. Food waste disposals can be grounded using any of the methods covered in the previous units, such as the separate bonding conductor of non-metallic sheet cable. Dishwasher. Although not a requirement of the CEC, the dishwasher is supplied by a separate 15-ampere circuit connected to circuit B5. Number 14 NMD90 conductors are used to connect the appliance. The dishwasher has a quarter horsepower motor rated at 5.8 amperes and 120 volts. The outlet for the dishwasher is shown by the symbol I. During the drying cycle of the dishwasher, a thermostatically controlled 750-watt electric heating element turns on. Use a 15-ampere circuit. For most dishwashers, the motor does not run during the drying cycle. Thus, the actual maximum demand on the branch circuit would be only the larger of the two loads, the 750-watt heating element. In some dishwashers, there is a fan or blower to speed up the drying time. In either case, for the dryer example shown, a 15-ampere circuit is more than adequate. Energy-saving dishwashers are equipped with a built-in booster water heater that allows the homeowner to adjust the regular water heater temperature to 50 degrees Celsius or lower. The booster heater of the dishwasher then raises the water temperature from 50 degrees Celsius to a temperature not less than 60 degrees Celsius for the wash cycle, and 80 degrees Celsius for the rinse cycle. The temperature considered necessary to sanitize dishes. Wiring the dishwasher. The dishwasher manufacturer normally supplies a terminal or junction box on the appliance. The electrician connects the supply conductors in this box. The electrician must verify the dimensions of the dishwasher so that the supply conductors are brought to the proper point. The dishwasher is a motor-operated appliance and requires running over current protection. Such protection prevents the motor from burning out if it becomes overloaded or stalled. Normally, the required protection is supplied by the manufacturer as an integral part of the dishwasher motor. If the dishwasher does not have integral protection, the electrician must provide it as part of the installation of the unit. Grounding. The dishwasher must be bonded to ground. The grounding of appliances is described fully in previous units and in the discussion of the food waste disposal. Portable dishwashers. Portable dishwashers have one hose that is attached to the water faucet and a water drainage hose that hangs in the sink. The obvious location for a portable dishwasher is near the sink, so the dishwasher probably will be plugged into the outlet nearest the sink. Portable dishwashers are supplied with a 3-wire cord containing 2 circuit conductors and 1 bonding conductor and a 3-wire grounding type attachment plug cap. If the 3-wire plug cap is plugged into the 3-wire grounding type receptacle, the dishwasher is adequately grounded. Whenever there is a chance that the user may touch the appliance and a grounded surface such as the water pipe or faucet at the same time, the equipment must be bonded to ground to reduce the shock hazard. Some appliances are double insulated, which means that the appliance or tool has 2 independent layers of insulation between the hot conductor and the person using the device. Although refrigerators, cooking units, water heaters, and other large appliances are not double insulated, many portable handheld appliances and tools have double insulation. All double insulated tools and appliances must be marked by the manufacturer to indicate this feature. These tools and appliances must be marked with the words double insulated or the rectangular symbol as specified in CSA Standard C 22.20. 0.1 M 1985. Cord connection of fixed appliances. As with the previously discussed food waste disposal, residential built-in dishwashers are permitted to be cord connected. Some electrical inspectors feel that using the cord connection method to connect these appliances is better than direct connection. Sometimes referred to as hardwired, because it allows them to be easily removed for maintenance and repairs.